Bismillah ar-Rahman ar-Rahim. Dear students, we have started the 3D graphics as we know from the last topic, and today we have the actual topic which may come in exam. That is your types of projection. So in the types of projection we have the parallel or perspective. We have a little bit discussed about that. Now it's time to go in detail and let's take up the perspective projection and what is perspective projection, and then 1 point, 2 point, and 3 point, how to actually basically it's all about to draw a 3D image on a 2D plane, right? Okay, let me show you some pictures, and let's talk about first a little bit about perspective, then we'll show some pictures which will get your concept cleared, and then we'll see how to draw it using the pen and pencil. So in the perspective projection, we actually have some object, and this is my projection plane, and the lines which are coming parallel appear to be, meeting at some point. It's called a center of projection or vanishing point. It's also called as a vanishing point, and these are the projectors. Uh, you can better understand this by some real world photograph. Okay. Now, if you look at this picture, okay, let me make it a little bigger, if it can. Okay, it's 1 second. I just want to make it bigger. Okay, now edit and create and draw. Oh, it gets back to it. No, not a problem. So if you see this picture, this is a parallel line road, which is different with parallel lines, but you see when you are looking in front of it, and you see these lines are coming together. Any line you draw on it, they meet at a 1 point, which is called as a vanishing point. So this is called as a vanishing point. Okay, any line you see that is going to converge on the same point. Okay, from wherever you see from the top, you see from the bottom, they are going to converge it into the single point, and this single point is my what's called as a vanishing point. This is your another example. If you could see the train, okay, we know there are parallel tracks all the time, but when you see it up front straightway, this is the real world, how we see our eye works. This is the dimensions of our eye. This is how the camera works or our eye works. Okay, that's why we say in perspective projection, you see things how they appear but not how they are. This is important because here if you see the track, it's not like this, that all the lines are merging to a single point, they're converging to a single point, which is what we call the vanishing point, where all the parallel lines, in fact they are all parallel. The railway track, it's parallel, right? But they are all coming to the single point. This is how our eye works. Okay, and that is why we say this is the perspective projection. This will not be good for engineers, because engineers can believe in what actual things are, how they are, because these are design things. But this is for the artist, for the somebody who is a who want to paint or who want to draw the real world scenarios. It's for them. Okay, let us take up the another picture. This is the Raffles philosophy, his first fresco decoration on a large wall of the Vatican chambers. And you see here, if you draw any line that's going to point to the center, and from anywhere you want to see it, for example, if you see this here, from anywhere you just want to see it, you put up any line, and they're going to converge to a single point. So this is an example of 1 point perspective again. Okay, so if you look at this 1 point perspective projection, okay, that means uh, something, any of the principal axis intersects with the projection plane. This is your projection plane. We should remember that x and y are parallel to the projection plane, and z, because we don't want to show it in a z, so it intersects with the projection plane. And the lines which come parallel actually converge to a particular 1 point, that will be called the vanishing point, which will be perpendicular to the principal axis. To draw a one perspective projection, we just first draw the horizon. That is the line of vision, right? This is my horizon, and horizon on the above is the sky and below is the ground. This is where this is the line of vision, I could say. Okay, then what we do is we create a vanishing point. Okay, so let me my vanishing point black color. It will be, say for example, on the horizon line. So this is my vanishing point. So on the vanishing point is where all the lines is gonna converge. Okay, then let's place some object, maybe a 3D object, which is maybe the cube, on the horizon again. So let me draw it here. It's getting too much. It'll be smaller. Okay. Now I got the this thing. Then I have to get the lines from my object. This is going to be cube, so I need to see how I will develop it and how one perspective actually works, and how actually artists or somebody who want to convert a 3D on the 2D, this thing will work with the lines. Okay, so now I will draw a line from meeting this to this. So I will travel back in a space that actually lines have traveled from the this cube to the this vanishing point. Okay, where it converges. Now what we do is from the vanishing point to this, we will draw some lines. I think I should draw a line, not just create a shape line. Okay, here we go. To give us a proper line, one from, again I want to have a line from this point to this point. Again I want to have another line from this point to this point, and another line from this point to this point. What I'm trying to say is these are the lines which are actually coming up from these points. Actually they have been coming from the object and onto the screen, then on the projection plane, and then converge it to a particular point, like we saw our railway track, or we saw our road, or whatever, right? Then it's time to draw the other square, because we want to draw the cube, right? What was the color of that? I don't know. Let me take this color, for example, here, smaller. Okay, now what I will do is no, I need some lines here. For example, I will draw a line from this to this. I can draw from any line from this to this. Then I will draw another line from this to where my this ends. Say for example here, it should be a little down. I don't know. Control Z. Oh, sorry. Redo. Can I redo? Yeah. Can't I redo it? Yeah. Now I just want this line. Now then I draw a smaller cube up front. Okay, you can put up any cube, anyone. It could be here, it could be here. So if you put a little forward, it will be a little bigger. But you see the other face, the front face is here, the other face is getting converged. It's getting smaller and smaller the more it goes towards the vanishing line. Okay, this is my vanishing line, vanishing line, this one, vanishing point, in fact, I should say. My square gets smaller and smaller. If you draw this square here, it will be very small, and so on if I go forward. So what I'm trying to see is my 1 point perspective is uh, to get all the lines converge towards a one single point. But it's not the always case, because sometimes we have 2 points, vanishing points, or sometimes we have 3 vanishing points. We need to understand that. But if you do the same thing with the this cube on the below the horizon, I need to change the color to something like that. Okay, or I if I make a cube over the horizon, so it's gonna be little different, right? The view is gonna be little different to project on the screen. you can simply fast forward it. Okay, later. So converge all the lines, and from this I need to one more line from here, from this point to this point. Then I need to draw a square. Okay, maybe I put a black line here, right? Okay, whatever. So that means this square should also be black, but nevertheless, if I put it anywhere, I just want to put a line from here. What is the shape? Line from here to here. If it gets straight, okay, then another line from here to here on this line, okay, and then another line from here to straight line. Actually, okay, it's not coming up properly. I need to select it, get it aligned. Come on, come on. It's better to draw with the pencil, I guess. Right, let me draw it. Let me draw it of my own. Okay, this is gonna be from here to here. Okay, and if I complete this view from here, then this one, then this one, then this one, then this one, obviously, and erase these little bit of lines. Okay, I need this line also here. So you could see this is my view of a square from one point perspective of this square, and from this one, if I talk about this one, then again I need to draw the lines. You can just fast forward your this from every corner to every corner. These lines are not coming from this is coming throughout, and I'm just drawing from the corners. Only those lines I'm drawing, right? And they all converge to a one vanishing point. No matter what lines they come up, I'm just taking some few lines here. Okay, here we go. It converges to one single point. Then we need to draw maybe using different color or what. Maybe I use a red color to show the front. I mean this one. So I can choose up anywhere in these lines. So if you go further and further, it will be smaller. Okay, so I have to join this one, then I join this one here, then I join this one here, right? So this will give me the view of a square, a cube. I guess I need here this line, then I need here this line, then I need here this line here like this. Okay, and maybe this line also, and I need this line. This one I don't need, rest I need to just erase it. I can erase this one too, and I can erase to give the proper look a little bit. So if I see from the top, it will look like this. Okay, but we need to draw the proper line with the scale. In a one point perspective, we just have a one we have a one point. Okay, let me make it a little bigger. We have a one vanishing point. Okay, say for example this is my that vanishing point, and everything converges to that. Okay, so if it is a road, for example, or whatever it is, Control Z and get different color, black color. If it is a road, for example, going on from this side, okay, of a vanishing point, and say for this is a road. Okay, let me take this as a road, and everything becomes smaller and smaller till we go to the vanishing point. Everything becomes smaller, smaller, and smaller. Let's consider, say for example, we have a maybe a building here. Okay, if I have a building here, this is gonna be a little bigger. Okay, because we're gonna have the lines on this side also. Let me make a smaller one, little smaller, which will go from here to here. okay, from this point to this point. Okay, so I need this line because everybody will go on this line. So now if I draw uh, another building here, for example, that's going to be little smaller. So this is a building with the block and with these windows, and this is a gate. This is a gate and the windows, three windows. And if I draw the same building here, it will look very smaller, right? And so on. And say for example, if I build a tree here, for example, I put up another line to show you guys this thing. So let me put up a line from here. Oh no, it's not. Let me get the shape from here. It's getting a little slower because there's a lot of drawing here. Now if I draw another point from here to here, for example, if I have a, say for example, some kind of trees which are growing here on this line, if we have some trees going on here, this line on here, it will be a little bigger, okay, then here it will be this much, and here it will be this much, on here it is going to be very little, on here is going to be very little, right? So everything converges, and everything gets smaller and smaller as it's going away and away from the projection plane and towards the vanishing point, right? Now we have what is called as a 2-point perspective. So what is a 2-point perspective now? So if we get back to this slide which we were seeing last time, so we are seeing that we have in the perspective projection we have a center of projection, okay, which is a finite distance from object, and the projectors are actually the rays, and initially they are actually the parallel, but then they become non-polar, okay, and they vanish into a point called vanishing point. But there are points because if it is a one perspective or two or three, depending on that, we have 2 points or 3 vanishing points. And then object appears smaller as distance from CP, okay, center of projection. Then center of projection will be the eye which is watching it, so it's gonna appear smaller. So we cannot have the determine exact size and shape of object. So but it's how, that's what I'm saying, the perspective projection is how things actually look in a realistic world rather than how they are actually, right? That's why for engineering we don't use the uh, perspective projections, we use rather the parallel projections and all, okay. And this 1 point or 2 point or 3 point are actually depending upon how many vanishing points we have. So in a 1 point we have just one vanishing point, and now the 2 point we are having two principal vanishing point. So what is that? Now just let us discuss this thing. Now if you look at this picture, we are having we are trying to see the double lane, okay, and in this lane we are having on one side all the lines are converging to this point, okay. So this is my principal axis, and on the principal axis I am getting two perspective, two converging points, two vanishing points, okay. As you could see here, you could see here, any line which gets converged to this point only, and all these lines gets converged to this point only, okay. So that means by this picture you could see there are the two vanishing points, because my picture is like I'm on a corner and I'm seeing two lanes going from left and right. And when I see it on a picture and I see it's say for example, if you get it a little confused, there is some cyclist or some person, it's far away and it looks so small, right? It looks so small. So that person, if that person comes up, it looks bigger, okay. If that person comes up from this side, it looks bigger and the actual size. The more it moves towards, it's actually converging. This is how our vision is, okay. It's converging, and if at one certain point it looks like a dot. That person will look like a dot. So that's the vanishing point. After that, the rays actually meet there and they vanish. Okay, after that they vanish. That's why we call them a vanishing point, because after that we can't see anything, because that's a point. That's why we call it a vanishing point, because those rays actually all vanish. Okay, so overall, you have a, say for example, you have a cube. Say for example, you have a cube, and then you have the projection plane. Where do you want to project the lines? Actually, they can come parallel. Okay, right? But after that, the lines actually, uh, these are the parallel lines. Then there are many lines which come up, which come up like this obliquely, and then they try to meet at some particular point behind this projection plane, which is actually the center projection, and which is actually the vanishing point. That's the vanishing point actually, right? So they kind of made, this this box is then made on here, on this projection plane, and the central line which we have is actually called the horizon. Okay, above which is actually sky, below which is actually my ground. Okay, and it depends on where from you are viewing. It gives you the 1 point or 2 point. In a 1 point, I was, straight on a track. I was looking straight down the track of a railway track, or on a road. I was so I was here. So if I'm here, for example, if I'm here and watching this way, then it will give me the 1 point perspective only. But I am now this time here, right? And I'm watching both ways. So that means my picture is, in my picture it comes both the lanes. Okay, and I get this perspective. If you could see this one, this part of the picture, it is bigger. Okay, it's the bigger, and then it gets smaller, 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 right? It is bigger, bigger. Then it, when you go forward, it's small, small, and converges to a particular point. Then if you see, any person from very far away, it looks small. And you may have seen people taking pictures of, like, that's what's called the perspective pictures. Like, they put up a hand there, and as if the moon comes in the hands, right? Let me show you this pic. If you just search on a Google the image for perspective, and you could see somebody, Eiffel Tower and something like that, and these roads, they all converge to a particular point. Okay, or you could see the sun in a, like these pictures. So because why sun looks so small? It's because it's so far away that it converges to just a one small point. It could see, you can just see it's coming up in a hand, because it's converging, right? It's all perspective. That's what we call the perspective photography, right? Now if we want to draw something of our own, the two perspectives, so we again need this horizon line. But now we cannot have one vanishing point, we need to have couple of vanishing points. So this is my horizon line. Okay, and I will have a couple of points on it. So these are going to be two vanishing points. Okay, vanishing point 1, vanishing point 2. Okay, okay. Now, like here, if we want to draw this, like this, this is kind of a cube, right? If we talk of this one, this here. So I need to first draw this line, the first line. If I want to draw the cube on having this kind of scenario, so I need to draw this line only first, right? So let me draw that here. Okay, so let me draw a one line here. Let it be black. Okay, or it may be blue. Let it be blue line from here to here, whatever. Okay, let me select this and get a little down. Okay, let it be like this. So this is my line, and this is the front line of a cube, because I want to see it because when I'm on a two perspective, I will be on a corner of a cube, and I want to see both sides of a cube. Okay, right? So how I should draw it now? I'm going to draw some lines from the vanishing point to the border of the cube, okay, to this edge, and draw another line from here to here, okay, to this point, if I could get it exactly, and another line from this vanishing point to here, because I am trying to see the edge of, I'm seeing from the corner edge of the cube, and try to see the both edges. Okay, I'm trying to see both edges of a cube, so that means I need to have a two vanishing points, and I'm drawing it. Then I'm gonna draw the edges which are on the side edges. For example, this is the one I need to draw a line, but okay, Control Z. Okay, I just want to draw a line from here to here. Okay, line number one, to see where my other edges are, and from here, but you have to draw the lines which are actually converging, I mean same size, same distance. I'm just going for a rough lines. So this much distance, this much of distance, so I will start from here and draw it. Is getting a little out, so don't worry. Anyways, so this is my thing. Then there will be the other lines also, from this line to here, which I will use a smaller, I will, oh no, I should not do this. Control C, control, yeah, in fact redo it. Now what I do is I need to deselect it and just go for the other lines from this color. So I need some other lines also which will converge from here to here, from here to here, because all the lines will come up, right? We need all the lines which are converging to the point from each and every edge. We need all those lines to have it. Okay, now overall my cube will be that I will do in the red, because this is my cube sides. Okay, and this will be here, and this is going to be here. Okay, it's the front side of my cube, which I could see these two sides. Okay, I'm seeing this side and this side. These black lines, which the gray lines I created, those lines will be on the other side of the cube, which will not be visible. So if I remove this line, okay, I remove this line, I remove this line, because these are the lines which are going away from the cube, so I could see the two sides of the cube like this. Okay, and you have to make it with the scale, and it will look nice. Okay, right now it's not looking nice. Okay, so if you draw it with the scale, with the proper perspective, is because proper from the proper point to the line, it will look a little better, right? So overall I could see the two faces of the cube. Okay, if I am having the two perspective. So that means what is this all about is how you position yourself to see the cube. Okay, and accordingly you have to plot this 3D on this 2D surface. Okay, I'm drawing the two on 3D, that cube on the 2D surface. This depends on how you actually see, and then how you actually project as a computer science student, right? Now we may be seeing this is now this cube we are viewing is no front on. We are looking from the corner, but front on. But what else if the cube is below and we are above the horizon? We are viewing it from the top. So then we may be viewing the top and the two sides. Okay, if it is the two perspective, right? So that means we need to draw first. We will draw the your horizon, this line. Okay, wait a second. We will draw the horizon. This is my horizon, for example. Okay, then if my line, which is let it be using the black. We'll use the black. Okay, so this is my front line. Okay, this is my front line. Now I need from the horizon. Okay, this should be red. Okay, change it to red. Okay, now I need two perspective points. Okay, I need the two vanishing points. Sorry, let these vanishing points be. Let it be, one is here, for example. This is my vanishing point, and this is another vanishing point. Okay, and I'm trying to look it from a top. This vanishing point is far away. This vanishing point is a little closer. Okay, now I will try to draw some lines here, shape. So drop from here to this end. Okay, sorry. Control C. One second. Okay, we want to draw this from this vanishing point line up to this point. Okay, then we need another line. Right now, from this vanishing point, from this point to the vanishing point. Okay, in fact, these lines are coming through. Okay, they go this way also and this way also and meet it here, and after that they vanish. Okay, so they are going, right? I will show it, but let me draw the other lines here from this point. Okay, from this point to the vanishing point, like this. And I need another point to the vanishing point, like this. Okay, to the top, I'm getting this two lines. Okay, then I will need to draw the vertical lines here. Maybe I drop it here. Okay, like this one, and another one. Maybe this one. Okay, Control C. Let me clear it a little bit. Now we need to draw the top. Okay, that means from this vanishing point to the top here. I'm not drawing it properly. Okay, so you should, because you see it's not meeting this, so we should draw it properly. And from this point to this vanishing point. Okay, so that will give me the top of the, because these rays will make the top. Okay, in fact, if you understand this, these rays are, they're going like this. They're going like this. Okay, all of these rays are going, and eventually they make the cube. Okay, and that means I'm viewing it, my horizon is my here, my eye, actually the observer is on this line, and the cube is little down. So if we just erase our, and we also know that there are other lines which join each and every of this, right? And this one, they're on the back of it, so we don't need them. And if I erase these lines which are, okay, if I, oh, I cannot, Control C to get it back, because if it will erase me whole. So eventually, if my cube, you see, if you remove those lines, these lines, this is my cube. The vision of the cube will be like this. You can see that this one, right? You can see it, this one. You can see this face, you can see this face, and you can see the top. And if you see on this way, they are converging to the vanishing point here, and if you see this way, they are converging to this vanishing point. So the vision will be like this. Same is with the above horizon. If I draw it, okay. Now, if we have our cube, which is if we are trying to actually do what? This is my Control Z. Once again, first I will make a horizon. Now this is my horizon, and you are, say, below, and your object is on top, and you are viewing it in two perspective, but from below you are seeing. So say it's like a cube in the air here, and you want to see it. So how will you see it? So first you draw, you are going to draw the, you know, the midline. Okay, then you need to combine these guys. Okay, let me get it a little smaller because it's, yeah, this one is good. Line. So I need to combine this point to this point, right? And then I need to combine from this point and start up to this point again. Then I need to, these are the rays which are actually making it. Okay, what I'm doing is the projectors which are actually projecting it. Then I need to combine this with this. Okay, and I need to combine this with this, right? So I got the front portion. Now I need to I need lines, horizontal lines of a side. Say for example, here is my one of the lines. Okay, and say for example, here is the other line. Okay, I need to complete it. Then for the bottom, I need to combine, because I can see now the bottom of the cube, because cube is on top of my head, for example. Okay, uh, so I'm just drawing roughly now. Okay, and once again select it. Get it up to this. Select this one, get it here. Get up to this. So it needs a little more time to actually work on it. Okay, and we will be good if we work it properly. Now whatever it is, so if I could see my cube in totality, it will be this guy, this side. Okay, this one and this one and this one and this one and this one. So I will get the bottom, I will get this side and this side, and on this side it converges to this vanishing point, and on this side it converges to this vanishing point, and overall your cube will look like this. So this sums up our 2-point perspective, and now we have a 3-point perspective. So what is 3-point now? So if you just see the couple more pictures for the 2 perspective, that you are on an edge of this building, which is like a cube. You could see on this side it's getting 1 point here and 1 point on the other side. Okay, and you could see the trees are getting smaller till it dimensions to a point, and same way on this side. Okay, and I have more pics like this one. Okay, so that means if this is some kind of a building, maybe some kind of a fort. Okay, and you are on the fort, on the corner of the fort, and you are viewing both of these sides, and they are converging to a point on this side and converging to a point on this side. Okay, so this was the 2-point perspective. And when we saw the 1-point perspective, that means you are not on a corner, you are viewing straight way, you are viewing full straight, and converges, just these parallel lines converge to a point. So 1-point perspective. Right, now there is the 3rd-point perspective, 3-point perspective. Now this is your 3-point perspective. You see, say for example, you are on a chopper and you are seeing on the corner of a building, like 2-point perspective. You are on a corner of a building, and you are not only watching this way. Okay, sorry, you're not only watching this way, but you're also watching this way, which was in a 2 perspective, but now you are watching on a bottom side also. So this makes it the 3rd dimension also. So you are converging. So if you just see the bottom side, this building, converges to this point here on the bottom. If you go down, it will converge to this point, and it looks like a tapering on the bottom. And if you say this way, it also looks tapering. Everything goes taper to the point. And if you look this way, everything goes taper to this point. Okay, and that makes it 3 perspective. I have a few more pics for this. Let me close this one. Okay, screen draw, close screen draw. As you could see here, if it's a cube, you are not only watching from this way, but you're also watching from this way and also watching from the bottom side, because they are all converging to the 3 points now. Like the 2 point, they're converging to the 3 points. That's the only difference, right? Another picture, same scenario. But you could do the same thing if the building or an object is on the top of the horizon, and you are not on the top, you're on the bottom, and you are, say for example here, then the story will be opposite. This point will be on top of the horizon, right? Now you may be wondering that if we had like this scenario, for example, what's the difference between the 2 point and 3 point? Say for example here, I am still watching it straight to this. I'm watching this way. This is little down, this is little down, and I'm watching actually this way and this way. Okay, and in the meantime I got the top. I'm not trying to watch down. Okay, that's the difference. Or in this case, I'm in a bottom, but my vision is on this way and this way. I am not trying to watch also the up. So in my picture, the top tapling doesn't come, but now in the 3 point, I will have a horizontal line. One will be point here, one will be here, one will be here. So I'm trying to watch this way, I'm trying to watch this way, and I'm trying also to watch this way. So my object will eventually taper to the point on the this axis also, and to this axis also, and to this axis also, right? So let's try to work out now with this. So what we have is, this is the horizon, okay, and these are the vanishing point 1, and this is vanishing point 2, and we need vanishing point 3. If you are on a chopper and trying to look down also, and we're on a chopper on a corner of something, some cube, say for example, and we want to see from this side and also from this side and also from the bottom. So that means my vanishing point, one of the vanishing point will be here also, right? So what I do is, first is I will try to draw some lines. Once again, Control Z. Let me get it little smaller line. Okay, now I need a line from this point onwards. I just move it this way. Then I need another line which will be from the same point and which will be like this way, for example. Okay, they are going, not a problem, and I need to intersect them with this point. I will have the couple of lines on this side this way, and another line from this point, say this way. They need to be equidistant or something like that, so that it will make some sense. Now they should intersect each other, and now I need a couple more lines from the vanishing point number 3rd. Say this is the straight one which is meeting to this. Okay, one, and it should be little, this point should be little sideways maybe, right? Let me fix it. Let me make it straighter. Let me make it straighter down here. Okay, let me, oh no, not a problem. 1 second. I will have my vanishing point that should be straight to this. First let me draw a line. Try to draw a straight line so that it looks a little straighter, right? Control Z. Draw a line from exactly this point. It's not getting exactly this point, I don't know why. Let me try again. From this point onwards to this point, and let me move it. I'm not able to move it exactly here. It should be exactly here. I don't know why it's not coming. Let it be like that. And then I need a couple more lines, one from this point onwards and one from this point onwards. Okay, 1 second, I'm coming. Now we are going to have few more lines which can intersect this point here. Should be exactly meeting this point here, right? And one more line which emerges from this point onwards and so on, and it can go forward. That doesn't matter because the lines doesn't stop. Okay, like this. Now among this, we want to see who is your what is your cube, for example. um, that's going to be this one, then going this one, and going, this is my midline. Okay, they meet it here, they meet it here, and this one and this one and this one. This is gonna be my cube. So I'm trying to look at my eyes here. Okay, uh, watching it this way, this way, and this way. So the cube will look like this. So I will have three vanishing points, 1, 2, and 3. Same thing we can do if we see from the bottom up. So but seeing on the three directions. I'm on a corner of a cube or a building, and I'm watching it on the road on the left, on the road on the right, and also on the top to the sky, right? So this is a 3-point perspective because we have, so what we are seeing is we have got um, we got three of these vanishing points. Okay, okay, so if you just simply shade this up, maybe bigger one, okay, to just give it a look of a cube, because I just made them, these lines closer, you just made them a little broader, these lines. Okay, so here you get this kind of a vision of the cube, and if you want to do it above the horizon, okay, this is the horizon and you want to have the point on top, the third vanishing point on the top, then it will look like this. Okay, so overall what 3-point perspective is that you are looking from the chopper, from the chopper onto the corner of a building, and from two sides and bottom, deep to the bottom, or in this case you are in a deep well, maybe in a down position, and then you are looking at the building on a corner and looking right and left all way and on top up to the sky. Okay, so that will be shown by the 3-point perspective, and this is how we then project it, this 3D image, on the screen. So 1-point perspective has only one vanishing point, 2-point has two vanishing point, and when it is a 3-point perspective, that it has three vanishing points. So vanishing point is where all the rays converge and meet, and after that they just vanish. And important point to note is the third point is not on the horizon, like 2-point or 1-point, the points were on the horizon. Here the point is not on the horizon, it's either above the horizon or below the horizon. So that's all for this video, and next we will be reading parallel projections. Okay, see you next time. Until then, ma salama.